Geotrig lesson 27. We're going to talk about signs of trig functions today. So, when we are talking about sine, cosine, and tangent, we've always been talking most of the time with just reference triangles. So 30, 45, 60s, and they've never been negative. But what we're going to do today is we're going to leave the first quadrant. Because in the first quadrant, everything is positive. X's, Y's, and all of those things. But when I move to a different quadrant, all of a sudden X becomes negative in the second and third quadrant. Y's are negative in the third and the fourth quadrant. So we came up with this nice little phrase that all students take calculus, and we go in that counterclockwise rotation, the same thing that we're numbering quadrants. And the first letter of all students take calculus helps us inform us of which of the three trig functions that you guys know are positive. All of them are positive in the first quadrant. Sine's positive in the second. Tangent's positive in the third. And cosine is positive in the fourth. All of the others are negative. So when we get to those other quadrants, they call them in this book related angles. And it says, remember, all angles originate from the positive x-axis. So you're always starting here. That's a bad circle. Here. And rotating in a counterclockwise rotation. Follows the sun from east to west, right? And so any angle that terminates in a quadrant other than quadrant 1 is what we call a related angle. And it has a reference angle to it. Those are those bluish purple things here that I have on the graph. So this angle here is a reference angle to this angle. This one is a reference angle to the angle that starts all the way around to here. Or the one that goes to here, you got a reference angle there. Now granted, they're not the only way in the positive or negative direction to get there. Now the thing is that this reference angle is always positive, and it's always an acute angle that's between the vector with the terminal side of your angle and the x-axis. Very important. So, how do I evaluate trig functions? Well, I got 5 steps, give or take here. And the first one is you've got to draw that angle that we're talking about. You draw the angle. So if I had an angle and we draw it here, there's an angle of 100 and some degrees. I'm just using this for example. And then it says make a triangle with the origin and the x-axis. So it kind of goes back to our days where we did polar to rectangular and rectangular to polar coordinate conversion. That same triangle is there where theta, the one that's at the origin, is the reference angle. Now, it says right here if it's not in the first quadrant. So it's the angle that's formed between the x-axis and your terminal side of the angle. If you're in the first quadrant, a reference angle is the actual angle you have. So it's kind of nice to know. At this point, you can just use SOHCAHTOA to find sine, cosine, and tangent. And then you just have to watch your trig signs. Sine is positive, tangent's negative, and cosine is negative in the second quadrant, at least on that example like this. So, what do they look like? Well, we're going to evaluate 4 cosine of 135. So the 4 is not the problem. It's the cosine of 135. What is it equal to? What is it something that I can refer that back to my reference triangles? So again, I'm going to draw that out. This is 135 degrees. Okay, which leaves me with this triangle. And in that triangle, I'm hoping everybody recognizes that I'll have a 45-degree reference angle. So what does it mean? It means that cosine of 135 is the same thing as cosine of 45. The only twist is we have to assign a positive or a negative to it. So I can then take out cosine of 135 and put cosine of 45 in there. And what I'm going to do is I left a little space here, right out front here, to kind of decide, is I'm going to put a positive there or a negative there? If it's positive, I'll leave it. If it's a negative, I'll put a negative there. And so you have to kind of go back to this idea that all students take calculus. Sine's the only positive one. We're talking about cosine. So yes, in fact, cosine of 135 is the negative of cosine of 45. And I think most of us should be able to say, hey, that means the negative 4 is there because the 4 times the negative. And now, using my reference triangles, or if we know it, I can just evaluate for the cosine of 45. And if you don't remember, draw them out. So 1 square root of 2. And like we did in class, we actually changed these. Oh, we haven't changed, we changed them now since we've already done this lesson. But cosine is adjacent over hypotenuse, which is 1 over square root of 2, or we change it to square root of 2 over 2. The 4 and the 2 cancel. I'm left with negative 2 times the square root of 2. And you are done. So I can do the same thing for the next problem. Again, the negative 2 is not going anywhere. I want to replace that cosine of negative 150 with something else. So where's negative 150? That's negative 90, someplace down here. And hopefully everybody recognizes that that would be a 30-degree angle. So that means I should be able to put cosine of 30 because it's the same as the reference angle to, negative 150. So the cosine of 30, but is cosine positive or negative in the third quadrant? If we go back to the problem we had above, tangent's the only positive one, so therefore it's negative, and negative makes a positive 2, and the cosine of 30, we don't have that triangle, so we'll quickly draw it out. 1, 2, 3, square root. Cosine of 30 is square root of 3 over 2. Where the 2's will cancel, and you're left with square root of 3. It goes that quick. So the same thing for the cosine of 300. 300 is all the way over here. And so I end up with a 60-degree angle because 300 plus 60 gets me all the way around. So now 5/3 times the cosine of 60. And is it positive or negative? Remember, all students take calculus. So C stands for cosine, so it is the cosine of 60. And if you go back to here, cosine of 60 is 1 over 2 or a half. So we get 5/3 times 1/2, which is 5/6. And that's it. Have a great day.